Hello everyone, welcome to the Study Hacks Institute of GIS and Remote Sensing. Today I will start the new series on hyperspectral remote sensing for sustainable agriculture. This tutorial. So basically, this is our first tutorial on hyperspectral remote sensing for sustainable agriculture. So today's session I will discuss about that how we can easily monitor the crop health using hyperspectral remote sensing in Google Earth Engine platform, and we can easily identify about that healthy vegetation and stress vegetation. Not only for that, we also monitor the soil properties, crop stress factor, contributing to the more efficient agriculture practice using hyperspectral imagery. And there are a lot of uses for potential sustainable agriculture due to its ability to capture detailed information across a wide range of wavelength. And traditionally, multispectral sensor, we capture data in only a few broad bands, but hyperspectral sensor collect data in hundreds of narrow band, and that's why we also get the more information. And you can easily precise the different types of monitoring, such as plant health, soil properties, crop stress factor, as well as also other. Okay, so I will try to show you all of this process, mainly how we can really use the hyperspectral remote sensing for sustainable agriculture. So today's session will discuss about that how we can easily use this imagery and make the crop health monitoring, as well as we also do for the soil condition analysis. It also possible using the hyperspectral sensor can be used to access the soil composition or share level, nutrient availability. So as well as it also identify the poor soil health, then also farmers can apply the precision agriculture technique, minimize the fertilizer use, and the enhancing the productivity. So this type of things I already discussed the further topic, as well as the precision irrigation and crop classification and yield prediction, okay, as well as sustainable land management and weed and pest detection, as well as soil erosion and degradation monitoring. So this type of things further tutorial I will discuss. So in the meantime, I discuss about that how we can easily monitor the crop health using hyperspectral imagery. Mainly in this time, I use here the neon. So basically, different types of hyperspectral imagery we can easily use, but all of hyperspectral imagery are not freely available in Google Earth Engine. So for that, when you want to work for any hyperspectral data in Google Earth Engine, it also better you simply download this imagery from other sources. Okay, so different types of sources we can easily get this type of hyperspectral data. So you try to download this type of data, and further you can easily use this type of data in Google Earth Engine. Simply upload this imagery, and then further analysis we can easily apply. So in this case, I want to use this data. So basically, this is the neon directional surface reflectance, and this data contain that there are 426 band. Okay, we find out that total 426 band. So basically, it's one kind of project. So this data set is available for the specific boundary, not for the whole world. So, but if you want download the neon data, basically, then for other study area, so then you need to you can simply download this neon data, as well as you can also contact. Here you can see they already provide some contact information. You can simply contact, and then you can, if you need this imagery neon, then you can simply get this type of image, as well as you also try to read this type of documentation. Okay, then you can easily get the more information about the neon hyperspectral imagery. So basically in this imagery, we find out the total 426 band. Okay, 426 band, and it's very high resolution. We find out that 1 meters. So this is the 1 meter resolution imagery, and here total 426 band. So here you can see all of band information you can easily get from here, and this band is the total 426 band we find out from this from here. Okay, as well as since the image properties we can get the image properties, you can see the unique visit number of neon site. You can also filtering use the image properties, term of uses. Okay, So all of details you can easily get it from this data catalog page. If you want, you can simply click on here, then you can easily get the developer data catalog page. Here you can see. So basically this data set is the part of publisher catalog, not managed by Google. So you can simply contact with this email for any problem, and also you can get the information from here. And this data set basically available provided the neon full form is the National Ecological Observatory Network. So this is the full form of the neon, and this data set is available from 2013 to 2021. Okay, and this data set mainly we find out that only for the 1 meter resolution, and here contains total 426 band. You can get all of information, we can easily get it. Also bands, also image properties. Okay, so now I want to use this imagery, and further I want to identify monitoring the crop health, where I find out that healthy vegetation, where I find out the stress vegetation. So basically further we can easily use the different types of algorithm. So in this case I want to use suppose NDVI, very normalized difference vegetation index, and then calculate the NDVI. Further we calculate about that healthy vegetation and stress vegetation. So in this case here you can see this is the data. Here I already import this data in my code editor. So this it's stored in this variable. We can get the neon directional reflectance imagery. So here we find out that you can see different types of directional reflectance imagery. So here you can see the 2013, 2014. Okay, we can get all of directionally. Just I simply print, then we can get all of those things. And further, I simply start date. Suppose I want to start from the 2017, and I take for the 1 year. Suppose 2017 January to December. Okay, so advance 1 year. It means that 2017 full year 2017, and I filter my image collection, and then filter by the neon site. So in this time I want to use here the GRSM. So it's the Great Smoky Mountains National Park. So this is the short form. So just I filtered this it one kind of metadata. So I simply put here the neon site, and I put here the GRSM. So GRSM is the Great Smoky Mountains National Park. It the short form. Okay, so neon site you can also suppose you need the other site. So for they can simply change the name, and for what is your region of interest, you can easily put your name about that. So here you can see the image properties. So here you can get this type of things. Here you can see the unique visit number of the neon site. Okay, so this is the unique visit of the neon site. Okay, so just put the neon site, then you can easily get. Suppose you need this data for the other study area, then simply put this name. So in this time I just use here this data for GRSM site. Mainly it's the Great Smoky Mountain National Park, and then I simply create the mosaic. Like mainly I take all of images and create this composite. Okay, and further I want to add the visualization. So in this case I try to show here the red, green, and blue band for RGB. So this is the red band, and this is the blue band, and this is the sorry, this is the green band, and this is the blue band. Okay, and I gamma correction for brightness. So if you want, you can also increase or decrease the gamma value. It's not. So you can see we can get this type of imagery. Okay, we can get for very high resolution. So basically it's that only for the 1 meter. Okay, pixel size is 1 meter. So that's why when you want to use this type of imagery, then we also get the more better information. And this imagery contains total 426, more than 426 band. Okay, and this type of band stored the different types of information. So that's why this type of hyperspectral imagery, there are a lot of uses in the agriculture sector or other types of sector than multispectral. So we got this type of imagery. So further I want to make the NDVI, and further I want to extract about that healthy vegetation, and also extract about the stress vegetation from this NDVI map. So it's very normal. We can simply calculate the NDVI using the formula of near infrared minus red band from neon hyperspectral imagery. So simply I call my imagery and select the near infrared band, and also select about that red band. Okay, around 665 nanometer and around 850 nanometer. So this is the near infrared band, and this is the red band. And further calculate the NDVI. So this very easy way, we just calculate the NDVI near infrared band subtract with red band divided by near infrared band plus red band. And then if you want to visualize the type of map, suppose just click on the NDVI, So now we can easily get this type of NDVI map for our study area. So we got this type of imagery. Okay, we can see this is the NDVI map, but this NDVI map we generate from hyperspectral imagery. So now further, I want to find out that healthy vegetation as well as also stress vegetation. So in this case, I want to consider the healthy vegetation is the greater than 0.8. I put here, and less than 0.6, all of vegetation I consider as a stress vegetation. So further, I want to show the result for healthy vegetation as a green color. So we can easily get this type of green color. So just okay, I find out that this type of green color, you can see it indicating about that healthy vegetation. Okay, and when I open this less than 0.6, it the stress vegetation I consider. So that's why you can get this type of red color. It identify about the stress vegetation. Okay, so basically this is the process. So it's one kind of normal process to identify for crop health and health monitoring, suppose stress vegetation, and also identify about that healthy vegetation. So now we got this type of map here, you can see, and this map is generated from hyperspectral imagery. So here you can see we can easily find out this type of map. So this is the healthy vegetation, we can easily get this type of place, and this is that stress vegetation, you can get the red color. And this is our NDBIMF we generate from neon hyperspectral imagery, and this is the imagery for that. Okay, just we use this imagery and then create this type of things. So basically this is the process we use the hyperspectral imagery. And further next tutorial today discuss about that how we can easily monitor the soil condition analysis as well as precision irrigation, then crop classification, yield prediction, and sustainable land management, weed and pest detection, and soil erosion and degradation monitoring. So this type of things I try to use the hyperspectral imagery. Okay, because when we are use the hyperspectral imagery, then we also get the more better result, because hyperspectral imagery have a lot of bands, more than 100 of narrow bands we can easily find out. Okay, but multispectral imagery we don't get this type of band. So that's why when you want to use the hyperspectral data, then we got the more better result. Okay, so if you want to watch this type of tutorial, simply keep in touch with this YouTube channel, as well as if you want to learn from my live training program. So basically we also conduct a live training program. If you want, you can also join my live training program and learn this type of things properly. And our next best class will be start from 20 September. From next week we try to start our new batch. And if you want to join this online training program, you can simply contact in this WhatsApp number as well as contact with this email. Okay, and if you want, you can also visit this website. So basically from this website you can get all of information. This website and all of information I already added in the video description. You can simply check it and check all of course content, mainly which you learned from the total 7 days online training program. All of things I already added in this website, as well as you also get it from my video description. And when you want to join this online training program, you can get some benefits, such as you can get the course certificate after submitting all of assignment. You can got all of materials, mainly slide, PDF. You can get all of practice code. Okay, as well as you also get the recorded class. If you miss any live training program, then you can easily cover using the recorded class, as well as finally you can get the lifetime teaching support. So it's very important as a beginners, because when you want to learn the Google Earth Engine for remote sensing analysis, you face a lot of problem. So that's why we are also providing the lifetime teaching support. So when you face any problem in your code or any issue in the remote sensing, you can get the support freely. Okay. So if you want to join this online training program, you can simply contact in this email as well as contact with this WhatsApp number, and then book your seat and join our WhatsApp group and also Google Classroom. So today is no more. Thank you for watching that. Stay happy, stay safe.